Hey guys, welcome to lesson 832 day 2. Today I'm not going to use a note sheet. Instead I'm just going to give you a demo of exactly how to do one of these open math problems, and so hopefully that is helpful. So not a ton of new stuff, but we're just kind of putting a couple things together in terms of finding roots of polynomials, and we're just going to bring graphing into this a little bit. So let's say I have this polynomial and my goal is to factor it and list its roots. So to do this, I'm going to start by graphing it. I am just going to use Desmos instead of the calculator, but of course both of them are great options. So I have already graphed this in Desmos, and keep in mind that we are trying to find integer roots. So when I go to Desmos here, I'll graph this, and we get this image right here. There are 3 roots that we can see, and I'm asking for an integer one. So if you zoomed into these two, hopefully you'll notice that these are not integers, right? This is negative 0.8, this is negative 0.5, so those are not whole numbers, but we want whole number root. So if you go over here, there is one that's a whole number. Right over here, there is a root at negative 5. So that's the one that we are going to use here. All right, so we'll go back here and we'll say that we have a root at negative 5. Okay, and that indicates that we have a factor that is x plus 5. Okay, and we know this, right? Whatever our roots are, in the parentheses, we have it, x plus or minus that root, but it's always going to be the opposite. So a negative 5 root indicates a plus 5 factor and vice versa. All right, so next we're going to go ahead and use our Polydoku to divide our polynomial by the factor that we found, and then figure out what our answer is, and then we'll go from there. So we're going to go ahead and do our polynomial divided by x plus 5. So I'm going to go ahead and put a 5 here. It's just like when we set it up, we have x plus 5 on the side, and we want to figure out this top gray portion. So we know the 10x cubed goes in here. X times what equals 10x cubed? That's going to be 10x squared. Down here, 10x squared times 5 is going to equal 50x squared. And then we've run out of information in the box to figure out the rest of these, but that is what this bottom portion is for. So we know that there's a total of, oh, I want to use a different color for this. We know that there is a total of 63x squared terms in this polynomial, just based on this term right over here. And so keeping in mind that the diagonals are always like terms in the Polydoku box, that means we have to ask ourselves, okay, right now we have 50x squared terms, and we need to get to 63. How do we get to 63? Well, we would have to add 13. So I'm going to put a 13x squared in this box, okay, because I know that when I add these two boxes together, I need to equal this number. All right, so that being said, we can find some more information now. Up here, x times what equals 13x squared? Well, that would be 13x. And then 13x times 5, that's going to be 65x. Oops, wrong color again. All right, 65x. So now I have to look again and say, okay, well, I am out of information again. So let's go ahead and look down here and say, okay, well, I have a total of 69 x's, and right now I'm at 65. So how do I get from 65 to 69? I have to add 4. So a positive 4x will go here. So that, when you add these two, you get this. And now I can find some more stuff. We can say that x times what equals 4x? Well, that would be 4. And 4 times 5 is going to be 20. All right, so now my Polydoku box is all filled out, and I've gotten my answer to the division that I just did. I just figured out that when I multiply, or when I do x plus 5 times this big polynomial up here, so it's 10x squared plus 13x plus 4. When I multiply these two together, I would get this polynomial. All right, so that's where it comes from. It comes from the left side and the top side of your box. All right, so now I've started to factor my polynomial, but it's not factored all the way. This quadratic right here, I can continue to factor even more, but as we saw in the graph, the factors that we end up with, or the roots, I should say, are not nice numbers. They're not whole numbers, so this is not some easy diamond in box factoring problem. So of course we have to fall back on our old friend quadratic formula. So let's go ahead and do that. So we have to use this polynomial and do quadratic formula on it. Okay. So let's go ahead and set that up. Let's just have a little reminder of what the quadratic formula is. It's opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2a. It's really ugly too. All right, so that being said, let's go ahead and identify what each of these pieces are. We know that a is going to equal 10. It's the one that's with the x squared term. B is going to equal 13. It's the one with the x term. And C is going to be 4. That's always just the number without any x's. So now we can go ahead and plug that into our formula in all the respective spots. So we have opposite of B plus or minus the square root of b squared, so our b is 13, minus 4 times a, or a is 10, times c, where c is 4, all over 2 times a. Our a is 10, so we're going to stick a 10 there. All right, now we've plugged everything in, and of course this is where we get to simplify everything one by one. So this becomes negative 13 plus or minus square root of 13 squared is 169. Negative 4 times 10 times 4 is negative 160, so minus 160. All over 2 times 10 is 20. Okay, let's continue simplifying that. So negative 13 plus or minus, this becomes 169 minus 16 is just 9, so I can replace everything in there with a 9 over 20. And then let's keep going. So I can simplify the square root of 9. I know that that equals 3. All right, so now let's go ahead and split these up into our two answers. All right, so one would be negative 13 plus 3 all over 20. And let's just go ahead and simplify that now. So negative 10 over 20. If you simplify this all the way, which you need to do, make sure you simplify all the way, we get negative 1/2. And the other one, you'll use the, oh, come on. All right, we'll use the minus sign. So minus 3 over 20. So in this case, we get negative 16 over 20. So if we simplify this, we can see that both the top and bottom, now, you can do this all in one step or you can go piece by piece. I'll just show you guys piece by piece just because maybe some of you guys do it that way. I can divide the top and bottom by 2 and get negative 8 over 10, but then I can see that these can still divide by 2 again, and that'll give me negative 4/5. Okay. So now I got my other two factors, which means I'm ready to write the rest of the roots and factors. So up here, we want to list all the roots, including the one we got from the graph. So from the graph, we had gotten negative 5, and these are my other two roots. So let's do another color. I like this one. So we have negative 5, negative 1/2, and negative 4/5. So in factored form, my final answer will be x plus 5. That's from the negative 5. X plus 1/2. It's from my negative 1/2. And x plus 4/5. And of course, that's from my negative 4/5. And that is it. That's how you do the problem on my open math. So there's just 2 of these for you to do there. And yeah, that's all for today.